In SAT2 physics, we use three models to describe light. The first model is the ray model, and in this model we look at light as light rays that's traveling in a straight path. And the second model is the sinusoidal waveform. And we look at light as waves in this model, as light has all the properties of wave. And the third model is called the wavefront model. It also describes light as wave, and to get this third model, we just have to consider only the crests in the second model. And we simplify the second model to get the third one because it's easier to consider waves like this in a 3D form. And later this will help us when we are investigating light through space and how light interact with each other. So out of the three models that we talked about, in the first of our few videos, we will only look at light as rays. So today our topic is reflection. The law of reflection tells us that the angle of light going in equals the angle of light going out, or the incident angle equals the angle of reflection. Notice the term here, we have incident ray forming incident angle with the perpendicular line to the surface. And that angle will equal to the angle of reflection, which is formed by the reflected ray with the perpendicular line. So let us apply the law of reflection to a photograph. The first type of reflection we will talk about is diffuse reflection. This is when the light from the sun encounters the surface of, for example, mountains or clouds. Because of their surfaces are rough, they will give out light in all kinds of random directions, and we call them reflecting light diffusely. The second type of reflection at work here is called specular reflection. This occurs when the surface is a flat and plain mirror. So we can start from a random point on the mountain. So we know the point is reflecting diffusely to all kinds of directions, so we can draw two directions to the water surface. After we have those incident rays, we can draw the reflected rays according to the law of reflection. If we extend those rays beneath the water surface, we will find that they are intersecting at a point. And if we use geometry, and we will find that there's two congruent triangles. So we get that the 2 points are actually equidistant to the water surface. So we get a symmetrical image beneath the water surface. If we perform this process for every point on the mountain, we will find together the mountain is reflected in the water and the image is symmetrical to the real mountain. We call this image a virtual image because remember we were extending the light rays to intersect and they are not actually intersecting themselves. So it's only their extension that caused the image. So here is a sample SAT problem. The question says, an object is 1 meter in front of a plain mirror. The image is... So pause your video and take some time to do this question. The correct answer to the previous question is E. So we can do this problem the same way we did for the mountain. We can choose a random point on the arrow, and we know that it's reflecting light diffusely, so it's giving off light in all kinds of directions. So we can draw two directions to the mirror, and then we have those incident rays. We can draw the reflected rays according to the law of reflection. And if we extend those reflected rays, they will intersect at a point behind the mirror. It will also be 1 meter to the mirror because we have shown that these 2 points are symmetrical. So if we do that process for every point on the mirror, we will get a virtual image that is 1 meter behind the mirror and upright. Another interesting property to know is the reversibility of light. That is, if the direction of light is reversed, the path of the light will still be the same. And that is why if I can see your eyes in the mirror, you can also see me. So if you like what we talk about today, remember to check out the 2 amazing physics clubs at our school. And if you like this picture, come to physics club and learn about the high school physics photo contest.